let's take our little program here, very simple program, and let's work on a piece of paper, pretty much, what's happening step by step. Okay, so let's try to make things so that you can see the program and my notes at the same time. Whoops, there we go, almost. Let's make this a little bigger. And let's try to work this way. Okay, so the stack diagram, which we are going to draw for this program, the first thing to understand about it is that it's not a compilation time concept. Okay, it's something that represents what happens at runtime as the code is being executed. So I'm trying to not go into full detail about the memory layout of a process, etc. This is better addressed probably in other offerings, but let's try to just summarize what's happening. Okay, when your program is loaded in memory, you will have different segment, different area in the address space of this program. One of them is a text segment. There is a data/BSS segment. I'm going to kind of consider both of them together, which is going to hold global variables, things like literal strings, things like that. And there is your stack, your program execution stack. Okay, when your program is starting, there is enough data pushed on that stack to just represent the parameters that have been passed to your program, to the main function of your program, if any. If we are looking here at the program example we have, this stack would contain an activation record, okay, for the main function. As we enter the main function of our program, we're going to store on an area of the stack all the information relevant to the main. So here's the information I was talking about a second ago. Then we have here a local variable A, B, W. Okay, all the local variables of the main function are going to be here. And we're going to assign them some value. This is what we are doing here. Okay, A is assigned 42, B 99, W is assigned 0. And when we come to execute this line here, W is assigned the result of calling sum on parameter A and B. Here's what's happening in a simplified version. Okay, another activation record is going to be put on the stack. This activation record corresponds to this invocation of the function sum. So there is going to be some system information, such as return address, okay, where we need to branch at after we're done running this function. But there's going to be also the parameters of this function. I'm going to shorten the names here into OP1, OP2, and you see how when you call a function, you push onto the stack, okay, new activation record which contain everything local to that function, everything that function is going to work with. So of particular interest for us right now is the fact that the parameters are pushed onto the program execution stack every time we call a function. Okay, so that's going to help you understand exactly what's happening with passing parameters by value. In this example, when we are invoking sum on A and B, as I already explained, the two parameters are evaluated. Okay, it's pretty trivial. These are simply two variables, okay, two local variables of the main. A evaluates into 42, the value 42, B evaluates into the value 99. These are the values that are actually copied and assigned here to our parameters. Okay, then we compute the sum of operand 1 plus operand 2, that's 42 plus 99, and we return that value. When we return that value, an easy way to understand what happens is to simply say that the activation record for that invocation of the function is simply wiped out of the stack. Okay, in practice it's not wiped out of the stack, but for all intent and purpose in this offering, it just disappears. Let's put it that way. Okay, it's not usable anymore, to be a little bit more exact. So this is what happens when we are done executing our function. Our activation record is no longer available. We return back to the main code here, the main function code, and we execute the next statement. So we are back inside this activation record. Okay, so that's a basic mechanic. Now, a couple of interesting things that this is going to help you understand. First thing, let's say that I have here a local variable result, okay, and I am assigning to it operand 1 plus operand 2. If I was not doing typos, that would be even better. And I'm going to return result instead of operand 1 and operand 2. So let's make sure syntactically this is okay. Okay, let's run it to make sure it's still doing the same job. Still doing the same job, so we didn't compromise our code. What does this do? Well, let's get back to our stack diagram here, and I'm going to try to clean up things a bit. The only thing that we did here is we added one local variable to our function. Okay, so when we are going to call this function here, okay, w equals sum ab, same thing is going to happen. op1 is created on the stack. This is activation record corresponding to this call to our function. And we have a local variable. Well, local variable, which I abbreviate here as R for result, go also on the activation record of the function they belong to when this function starts being executed. So here's our result, and we're going to pass the parameter as previously, okay, by value. So the value 4299 are copied into op1, op2. We make the sum of those two values, okay, we get the result 141, which is assigned to this local variable result, okay? And then when we return the value of result to whoever called us, and again, this whole activation record here is going to be wiped out of the stack. So we didn't change any feature of the program. The only thing I wanted to illustrate here is the fact that your local variable in function, just like in methods in Java and C++, are exist only on the program execution stack, exist only inside the activation record of the function, and this activation record is created when the function is invoked. Okay? Alright, what's next? Well, if I modify result like I do here, okay, I'm going to put a new value inside of result, like 141. This has absolutely no impact on any other activation record that's currently on the stack, okay? Namely, if I add a variable result inside of the main, well, I would be working with this variable result, not any result variable which would be in the main activation record, okay? So that helps you understand where does the rules about the scope of variable, etc. come from, alright? Now, I can modify all of my local variable without impact on over activation record. That also means that I am able here to modify my parameters. Okay, it doesn't make much sense. Okay, this is not something useful that I'm writing here. This is just something useful to help you understand how the language behaves. All right. So, for example, here, for reason whatever, I am deciding that I'm going to set operand 1 and operand 2 to 0. Okay, and this is going to be absolutely having no effect whatsoever on the result of the program, obviously, but also on the values of a and b inside the main function. So this is what I want to make extremely clear. Okay, with this new version of the code, as I'm executing the function sum, okay, I'm going to have op1 set to 42 and op2 at 99 when I call the function. I'm going to compute the result 141 and store it in the variable result, local variable results, and then I'm going to do this. I'm going to go inside op1, op2, and I'm going to assign 0. As you can see, and this is the advantage of being able to make the stack diagram, modifying op1, op2 has absolutely no effect on a and b. Okay, so far all we've discussed about function calls in the C language, everything is always called by value. Every single parameter that you use is a call by value. If I was to write a function swap, which I would expect to take a and b, okay, as parameter, and I would like this function to be able to swap the content of variable a and b being local variable in the main, with what we've covered so far, we are not able to do that. We'll have to use pointers to be able to do this.